There is nothing you need to do right now, just listen and let your mind rest gently on these quiet facts about space. Everything here is calm, simple, and slow. The Sun is so large that about 1 million Earths could fit inside it. That is simply how things are, out there in the quiet of the solar system. Welcome, this is a place where there is no rush, no urgency, and nothing to figure out. You are here to rest while soft facts about space drift slowly past you one after another without any pressure. Space is large and still and mostly empty, and the facts about it tend to be the same way: wide, gentle, and easy to hold. You do not need to remember anything you hear. You do not need to stay awake for any particular moment. Everything in this video moves at the same slow pace from beginning to end, and you are welcome to close your eyes at any point and simply let the words continue without you. There is always more. There is no ending you need to reach. Just breathe and let space be large around you. The universe is estimated to be about 13.8 billion years old. That number is so large it has no real meaning to the human mind, and that is fine. It simply means that space has been here for a very long time, quietly doing what it does with no urgency at all. Light travels at approximately 299,792 kilometers per second. Even at that speed, it takes light about 8 minutes to travel from the Sun to the Earth. So when you look at the Sun, you are not seeing it as it is right now, you are seeing it as it was 8 minutes ago. The Sun you see is already in the past. The nearest star to our Sun is called Proxima Centauri. It is about 4.24 light-years away. That means if you traveled at the speed of light, it would still take more than 4 years to reach it. At the speeds of current spacecraft, the journey would take tens of thousands of years. The distances in space are so large that they almost have no meaning at all. They are simply vast and quiet and still. There are more stars in the observable universe than there are grains of sand on all of Earth's beaches. That estimate sits at somewhere around 2 trillion galaxies, each containing hundreds of billions of stars. The numbers become soft and meaningless after a while, which is part of what makes space so restful to think about. It is simply too large to worry about. Saturn is the 6th planet from the Sun and is known for its rings. Those rings are made mostly of ice and rock, and they are very thin compared to how wide they are. The rings stretch out for hundreds of thousands of kilometers, but in many places they are only about 10 meters thick. From certain angles, Saturn's rings almost disappear entirely because they are so flat. Jupiter is the largest planet in our solar system. It is so large that all the other planets could fit inside it with room to spare. Jupiter has at least 95 known moons. One of them, called Ganymede, is larger than the planet Mercury. It is the largest moon in the solar system and has its own magnetic field. Mars has the tallest volcano in the solar system. It is called Olympus Mons. It rises about 22 kilometers above the surface of Mars, which is roughly 2.5 times the height of Mount Everest. Olympus Mons is so wide that if you stood at the center, you would not be able to see the edges. The base of the volcano is about 600 kilometers across. The surface of Venus is hotter than the surface of Mercury, even though Mercury is closer to the Sun. This is because Venus has a very thick atmosphere made mostly of carbon dioxide, which traps heat and keeps the surface at an average temperature of around 465 degrees Celsius. It is the hottest planet in the solar system. Pluto was considered the 9th planet for many years. In 2006, it was reclassified as a dwarf planet. It is smaller than Earth's moon. It takes Pluto about 248 Earth years to complete one orbit around the Sun. By the time you have lived one full year on Earth, Pluto has moved only a tiny fraction of the way around its long, slow path. Neptune is the farthest planet from the Sun in our solar system. It was discovered in 1846 not by observation but through mathematics. Astronomers noticed that Uranus was not moving exactly as predicted and reasoned that another planet must be pulling it. They calculated where that planet should be and looked there, and Neptune was exactly where the math said it would be. Uranus rotates on its side. Its axis is tilted at about 98 degrees, which means it rolls around the Sun more like a ball than a spinning top. This also means that its poles experience about 42 years of sunlight followed by 42 years of darkness. It is a slow and quiet rhythm stretched across decades. Space is not completely empty. Between the stars and galaxies, there's a very thin scattering of gas and dust called the interstellar medium. In some places, this material gathers into large clouds called nebulae. These clouds can be the birthplaces of new stars, where gravity slowly pulls gas and dust together over millions of years until the pressure at the center becomes great enough to start nuclear fusion. Stars are born slowly in the quiet dark between other stars. The Milky Way galaxy is the galaxy we live in. It is a barred spiral galaxy, which means it has a central bar-shaped structure with spiral arms extending outward. Our solar system is located in one of those arms, about 26,000 light-years from the center. The Milky Way is approximately 100,000 light-years across. It takes the solar system about 225 to 250 million years to complete one orbit around the center of the galaxy. That orbit is sometimes called a cosmic year. The center of the Milky Way contains a supermassive black hole. It is called Sagittarius A. It has a mass of about 4 million times the mass of our Sun. Despite being so massive, it is currently in a quiet state. It is not actively pulling in large amounts of material right now. It simply sits at the center of the galaxy, dense and still, the way very heavy things tend to be. Black holes form when a massive star reaches the end of its life and collapses under its own gravity. The collapse happens very quickly, and the result is a region of space where gravity is so strong that nothing, not even light, can escape once it crosses a certain boundary. That boundary is called the event horizon. Beyond it, the laws of physics as we understand them stop working in the usual way. What happens inside a black hole is something that current science cannot fully describe. There is a type of star called a neutron star. It forms when a massive star explodes in a supernova and the core that remains is compressed to an extraordinary degree. A neutron star can contain more mass than our Sun, packed into a sphere only about 20 kilometers across. The density of a neutron star is difficult to imagine. A single teaspoon of neutron star material would weigh about as much as a mountain. Neutron stars sometimes spin very rapidly and emit beams of radiation. When those beams sweep past Earth, we detect them as regular pulses. Stars like this are called pulsars. White dwarf stars are what remains after a smaller star like our Sun reaches the end of its life. The Sun will eventually expand into a red giant, engulfing the inner planets and then shed its outer layers. What is left will be a white dwarf, a dense, slowly cooling remnant about the size of Earth. White dwarfs do not undergo fusion. They simply cool over billions of years, radiating leftover heat into space. Eventually, in the very far future, they will cool completely and become dark objects called black dwarfs. However, the universe is not yet old enough for any black dwarfs to exist. The cooling simply takes longer than the current age of the universe. The Andromeda Galaxy is the nearest large galaxy to the Milky Way. It is about 2.537 million light-years away. Despite that enormous distance, Andromeda is moving toward the Milky Way. In about 4.5 billion years, the two galaxies are expected to collide and merge. The merger will happen very slowly over hundreds of millions of years. Because galaxies are mostly empty space, the stars within them are unlikely to collide directly. The two galaxies will pass through each other and gradually reshape into a single, larger galaxy. The process is calm and slow in the way that most things in space are calm and slow. Cosmic microwave background radiation is a faint glow of microwave radiation that fills the entire universe. It is the leftover energy from the very early universe, released about 380,000 years after the Big Bang. Before that point, the universe was so hot and dense that light could not travel freely. When the universe cooled enough, light was released and began to travel. That ancient light, stretched and cooled over billions of years, is what we detect today as the cosmic microwave background. It is nearly uniform in all directions, varying only by tiny amounts. It is one of the quietest and most ancient things in the universe. The observable universe is about 93 billion light-years across. This is larger than you might expect given that the universe is only 13.8 billion years old. The reason is that space itself has been expanding since the Big Bang. The light we can see comes from regions of space that have since moved much farther away, carried by the expansion of space itself. There are parts of the universe so far away that the light from them will never reach us, because space between here and there is expanding faster than light can cross it. Those regions are beyond our observable universe and will remain forever unreachable and unseen. Dark matter is a form of matter that does not emit, absorb, or reflect light. It cannot be seen directly. Its existence is inferred from the way galaxies behave. Galaxies rotate in ways that cannot be explained by the visible matter alone. The outer parts of galaxies spin at roughly the same speed as the inner parts, which suggests that there is a large amount of invisible mass distributed throughout and around the galaxy. That invisible mass is what scientists call dark matter. It makes up about 27% of the total energy content of the universe. Ordinary matter, the kind that stars and planets and people are made of, makes up only about 5%. Dark energy is even more mysterious than dark matter. It is thought to be the cause of the accelerating expansion of the universe. In 1998, astronomers discovered that the universe is not just expanding, but expanding at an increasing rate. Something is pushing space apart. That something is called dark energy. It makes up about 68% of the total energy content of the universe. Despite making up the majority of everything, dark energy is almost entirely unknown. It does not interact with matter in any known way. It simply spreads through all of space, quietly driving everything apart. Speed of light in a vacuum is about 299,792 kilometers per second. Nothing with mass can reach that speed. As an object with mass moves faster, it requires more and more energy to continue accelerating. At the speed of light, it would require infinite energy, which is why it is not possible. The speed of light is a kind of absolute limit, built into the structure of the universe. It also means that information cannot travel faster than light. Two things that are very far apart cannot affect each other instantly. There is always a delay defined by the distance between them and the speed of light. Time passes more slowly in stronger gravitational fields. This was predicted by Albert Einstein and has been confirmed by precise measurements. Clocks at sea level tick slightly more slowly than clocks at higher altitudes because the gravitational field is slightly stronger at sea level. Near a black hole, time slows dramatically. At the event horizon, time would appear to stop entirely when viewed from the outside. This is not a mechanical effect but a property of spacetime itself. Gravity is not just a force. It is a curvature of the fabric of space and time, and moving through that curvature changes the rate at which time passes. The International Space Station orbits Earth at an altitude of about 400 kilometers. It travels at approximately 7.66 kilometers per second, which means it completes one full orbit around Earth in about 90 minutes. The crew members aboard the station see about 16 sunrises and 16 sunsets every single day. The station has been continuously occupied since November 2000, making it one of the longest continuously inhabited structures ever built by humans. It is a quiet place in many ways, floating in the dark above the atmosphere, circling the planet in steady, unbroken loops. Astronauts who spend extended time in space experience several changes in their bodies. Fluids shift toward the upper body because there is no gravity pulling them down. The spine can lengthen slightly, making astronauts temporarily a little taller. Muscles and bones can weaken without the constant resistance of gravity. The heart changes shape slightly because it does not need to work as hard to pump blood upward. These changes are gradual and quiet, the body slowly adapting to a new environment with no up and no down. The moon is slowly moving away from Earth. Each year it drifts about 3.8 centimeters farther from us. This is caused by tidal interactions between the Earth and the moon. As the moon pulls on Earth's oceans, creating tides, the energy involved gradually pushes the moon into a slightly higher orbit. This process has been going on for billions of years. Early in Earth's history, the moon was much closer than it is today, and the tides it caused were far more powerful. Over billions of years more, the moon will continue to drift slowly outward. The moon is the only place beyond Earth where humans have stood. 12 people walked on the moon between 1969 and 1972. The footprints they left are still there. Because the moon has no atmosphere, there is no wind to disturb them and no weather to wear them away. The footprints will remain largely intact for millions of years, until micrometeorite impacts gradually smooth the surface over an extremely long period of time. In that way, the traces of those visits are preserved in the silence of the lunar surface. The surface of the moon is covered in a layer of fine dust and broken rock called regolith. It was created over billions of years by the constant bombardment of micrometeorites and the expansion and contraction caused by temperature changes between lunar day and night. The temperature on the moon can swing from about 127 degrees Celsius during the day to about minus 173 degrees Celsius at night. The regolith is very fine and clingy, and the astronauts who visited the moon found that it stuck to everything and was difficult to remove from equipment and suits. Mercury is the smallest planet in the solar system and the closest to the Sun. Despite being so close to the Sun, Mercury is not the hottest planet. Because it has almost no atmosphere, it cannot retain heat. The side facing the Sun becomes extremely hot, while the side facing away becomes extremely cold. The temperature difference between the sunlit side and the dark side of Mercury can be more than 600 degrees Celsius. It is a world of extremes, though not the kind that come with any drama. They simply exist quietly on a small rocky planet close to a star. The Sun is classified as a yellow dwarf star, though it actually appears white from space. The atmosphere of Earth scatters shorter wavelengths of light, which is why the Sun appears yellowish from the ground. The Sun is about 4.6 billion years old and is roughly halfway through its main sequence life. It will continue fusing hydrogen into helium at its core for another 5 billion years or so. The energy released by that fusion is what provides light and warmth to Earth. The process happens continuously, without pause, deep inside the Sun, far from anything we can directly observe. The Sun's outer atmosphere, called the corona, is much hotter than its surface. The surface of the Sun is about 5,500 degrees Celsius, while the corona can reach temperatures of 1 to 3 million degrees Celsius. The reason for this temperature difference is not fully understood. It is one of the ongoing questions in solar physics. The corona extends millions of kilometers into space and is visible during a total solar eclipse as a soft, pale glow around the darkened disk of the Sun. Solar wind is a stream of charged particles that flows outward from the Sun in all directions. It travels at speeds of about 400 to 800 kilometers per second. When solar wind reaches Earth, it interacts with Earth's magnetic field. Most of it is deflected, but near the poles, some particles enter the atmosphere and create the auroras. The northern lights and southern lights are the visible result of charged particles exciting gas molecules in the upper atmosphere. The colors depend on which gases are involved and at what altitude the interaction occurs. Oxygen at higher altitudes produces red. Oxygen at lower altitudes produces green. Nitrogen produces blue and purple. Comets are small, icy bodies that orbit the Sun in long elliptical paths. When a comet comes close to the Sun, the heat causes its ice to turn directly into gas, releasing dust and creating the glowing tail that comets are known for. A comet actually has two tails. One is made of dust and curves gently along the path of the comet's orbit. The other is made of ionized gas and always points directly away from the Sun, pushed by solar wind. The two tails can point in slightly different directions depending on the comet's position. Most of the time, comets are too far from the Sun to be active, drifting silently through the outer solar system. Asteroids are rocky bodies that orbit the Sun, most of them found in the asteroid belt between Mars and Jupiter. They are leftover material from the formation of the solar system, never gathered into a planet due to the gravitational influence of Jupiter. The asteroid belt sounds crowded but is actually very sparse. The average distance between asteroids is enormous. Spacecraft have passed through the asteroid belt without any difficulty. Most asteroids are small and irregular in shape, tumbling slowly through space on their long, quiet orbits. The Voyager 1 spacecraft is the most distant human-made object ever. It was launched in 1977 and has been traveling away from Earth ever since. It crossed into interstellar space in 2012, passing beyond the heliopause, the boundary where the Sun's solar wind gives way to the interstellar medium. As of recent years, it is more than 23 billion kilometers from the Sun. Signals from Voyager 1 travel at the speed of light and still take more than 22 hours to reach Earth. The spacecraft continues to send back data, powered by a small nuclear generator that slowly loses power over time. The heliopause is the boundary that separates the solar wind from the interstellar medium. It is the edge of the heliosphere, the vast bubble of space influenced by the Sun's solar wind. Beyond the heliopause, the interstellar medium takes over. This is the region between star systems, filled with a thin scattering of gas and dust. Voyager 1 is now moving through this region, sampling it and sending information back. It is a slow and quiet journey, continuing outward at about 17 kilometers per second, growing more distant from the Sun with every passing moment. The Oort cloud is a theoretical region far beyond the known planets of the solar system. It is thought to be a vast, spherical shell of icy bodies surrounding the Sun at distances of up to 100,000 astronomical units. 1 astronomical unit is the average distance between Earth and the Sun, about 150 million kilometers. The Oort cloud has never been directly observed, but its existence is inferred from the behavior of long-period comets, which appear to come from all directions and from very great distances. The outer edge of the Oort cloud may mark the very limit of the Sun's gravitational influence. Beyond the Oort cloud, the gravitational influence of the Sun fades and the space between star systems begins in earnest. This interstellar space is not completely empty but is filled with a very thin medium of gas and dust. The density is extremely low, far lower than the best vacuum that can be created in a laboratory on Earth. In a cubic meter of interstellar space, there may be only a few atoms. It is a vast, cold, nearly empty expanse, stretching between every star in the galaxy. Stars are not distributed evenly throughout galaxies. They tend to cluster in regions, and along the spiral arms of spiral galaxies like the Milky Way. Between star systems, the distances are so large that even traveling at the speed of light would make journeys take years. The star nearest to our own, Proxima Centauri, is part of a triple star system called Alpha Centauri. The two larger stars in the system, Alpha Centauri A and Alpha Centauri B, orbit each other at a distance comparable to the distance between our Sun and Uranus. Proxima Centauri orbits much farther out, taking about 550,000 years to complete one orbit around the other two. Proxima Centauri is a red dwarf star. Red dwarfs are the most common type of star in the Milky Way. They are smaller and cooler than our sun and burn their fuel very slowly, which means they can last for trillions of years. The universe is not yet old enough for any red dwarf to have reached the end of its life. They are the longest-lived stars, quietly fusing hydrogen in the dark between larger, brighter stars that burn faster and die sooner. There is a planet orbiting Proxima Centauri called Proxima Centauri b. It orbits within the habitable zone of its star, the region where temperatures might allow liquid water to exist on the surface. However, because Proxima Centauri is a red dwarf, it produces frequent and powerful flares of radiation. Whether Proxima Centauri b has an atmosphere capable of protecting a surface from that radiation is not known. It remains one of many quiet questions about planets around other stars. The study of planets around other stars is called exoplanet science. The first confirmed detection of an exoplanet orbiting a sun-like star was made in 1995. Since then, thousands of exoplanets have been discovered. They come in a wide variety of sizes and types. Some are gas giants larger than Jupiter. Some are rocky worlds smaller than Earth. Some orbit very close to their stars, completing an orbit in just a few days. Others orbit at great distances, taking hundreds of years to complete a single circuit. The variety of planetary systems discovered so far suggests that planets are common throughout the galaxy. The James Webb Space Telescope was launched in December 2021 and began science operations in 2022. It observes the universe primarily in infrared light, which allows it to see through dust clouds and observe very distant objects whose light has been stretched into infrared wavelengths by the expansion of the universe. It has provided detailed images of galaxies in the early universe, star-forming regions, and the atmospheres of exoplanets. The telescope operates at a point in space called L2, about 1.5 million kilometers from Earth in the direction away from the Sun. At that location, it can maintain a stable, cold environment necessary for its sensitive infrared detectors. Infrared astronomy reveals things that cannot be seen in visible light. Stars forming inside dense clouds of gas and dust are invisible to ordinary telescopes because the dust blocks visible light. Infrared light passes through the dust more easily, allowing telescopes to see into the heart of star-forming regions. The infrared universe is full of objects and structures that are simply invisible to our eyes. Seeing in different wavelengths of light is one of the ways astronomers have come to understand the full complexity of what the universe contains. Radio astronomy is another way of observing the universe. Radio waves are a form of electromagnetic radiation with much longer wavelengths than visible light. Many objects in space emit radio waves, including pulsars, galaxies, and the cosmic microwave background. Radio telescopes can be very large because longer wavelengths require larger collecting areas to achieve good resolution. Arrays of radio telescopes spread across large distances can work together to simulate a single telescope the size of the entire array. The Event Horizon Telescope, which produced the first image of a black hole's shadow, used radio telescopes spread across the Earth, effectively creating a telescope the diameter of the planet. The image of the black hole at the center of the galaxy M87, released in 2019, showed a bright ring of light surrounding a dark central region. The bright ring is caused by hot gas swirling around the black hole and emitting radiation. The dark region in the center is called the shadow of the black hole, where light is bent and captured by the extreme gravity. The black hole at the center of M87 has a mass of about 6.5 billion times the mass of our Sun. It is one of the largest known black holes. The image took years of data collection and processing to produce, drawing on observations from telescopes on multiple continents. Space exploration has always moved at a slow and patient pace. Missions are planned years or decades in advance. Spacecraft take years or decades to reach their destinations. Data returns slowly across enormous distances. The results accumulate gradually, one observation at a time, building a picture of the universe that grows more detailed with each passing year. There is no urgency to it. The universe has been here for 13.8 billion years and will continue for an unimaginable time to come. The understanding of it grows slowly, quietly at the pace that careful observation allows.